Hey guys, this is part 3 for math for paper 3H from June 2010. And for this video I'm only going to be using red, just for fun. Well, for question 15, it says that the light intensity E is proportional, this is the symbol of proportionality, to the square of, inversely proportional to the square of the distance R. When something's inversely proportional, it's 1 over something. So in this case, it's R squared because it's square of R. So it's inversely proportional to 1 over R squared. Now, if I was to write this in terms of an equation, it would be E is equal to K times 1 over R squared. Now they've given us the values of E is equal to 4 when R is equal to 50. So we need to find out K to actually determine a proper equation. And that's what actually 15a is asking us, to express E in terms of R. So, 4, we'll substitute the E value. 4 is equal to K times 1 over 50 squared. So, we multiply both sides by 50 squared. We're going to get K is equal to 4 times 50 squared, which is nothing but 10,000. So now we take this K value and we substitute it back into the equation to get a full equation. So we're going to get E is equal to 10,000 over R squared, because 10,000 times 1 is 10,000. 15b is asking you to calculate the value of E when R is equal to 20. Now from the previous question we determined a formula. E is equal to 10,000 over R squared. Now in this case, all we got to do is substitute R into this equation. So we're going to get E is equal to 10,000 over 20 squared. And so E is equal to 10,000 over 400, which is equal to 25. Okay, so next question, we're asked to calculate R when E is 1,600. Similar to the previous question, all we got to do is substitute an E value. So we just get 1,600 is equal to 10,000 over R squared. Multiply both sides by R squared and divide by 1,600. You're going to get R squared is equal to 10,000 divided by 1,600. So R squared is equal to, is equal to square root of 100 over 16, which is equal to 10 over 4, which is equal to 2.5. So R is equal to 2.5. So in question 16, we're being asked to prove this is equal to this. So first of all, what we got to do is I'm going to take the left-hand side over here and do it. I'm going to prove it. So 3 minus root 5 the whole squared. Now 3 minus root 5 the whole squared is not 3 squared minus root 5 squared. Please don't make that stupid mistake. Many people make it. It is actually 3 minus root 5 multiplied by 3 minus root 5. So now all you got to do is do your expansion of brackets. Multiply each value by each term. So you're going to get 3 times 3, which is 9, minus 3 times negative root 5 is minus 3 times root 5. And minus root 5 times 3 is minus 3 times root 5. And negative root 5 times negative root 5 is nothing but positive 5. So 9 plus 5 is nothing but 14. Negative 3 minus negative 3 is negative 6 root 5 plus 14. So that means if we just arrange it properly, it would be actually 14 minus 6 times root 5, which is equal to this side. So you've proved it. Okay, so two prisms P and Q are similar. So when two prisms or two shapes are similar, all of their angles are equal to each other. All corresponding angles are equal to each other, meaning the ratio of sides and areas can be compared. So first of all, since they're similar, we can compare corresponding sides. So these two correspond. So if I did the larger triangle, Q in terms of the smaller triangle, so Q to P, I would get 18 is to 12, right? Now, basically what I can do is, with similar shapes, when I square, like think about, sorry, I'll just explain what the question is. The question is basically asking you to calculate the total surface area of prism Q, and they've given you the total surface area of prism P. Now, area is nothing but, think about area. So length is measured in centimeters, area is measured in centimeters squared. So area is nothing but length squared. So with similar triangles, since we can compare their sides, we can also compare their areas. And area is nothing but the length squared. So the ratio of areas is equal to 18 squared is to 12 squared. So we're going to get, actually first of all, let's simplify this ratio. Makes it simpler. Q is to P, so 18 is to 12. So that means if I divide 18 by 12, I'm going to get 1.5 is to 1. Now, as I said, you can just square both of the lengths to get a ratio in terms of area. So you're going to get 1.5 squared, which is 2.25 is to 1. And this is in terms of bigger to smaller. So now if 2.21, and this is for area, while this is for length. So if 2.25 is to 1, that means the surface area of prism P, x, which is the surface area of prism Q, which is what we want to find, is to the surface area of prism P, 544. Now putting this in algebraic form, we're going to get, one second, let me erase. We're going to get 2.25 over 1 is equal to x over 544. So x is equal to 2.25 times 544. So the total surface area of prism Q is nothing but 1224 centimeters squared. Okay, 18 is really simple, just being asked to simplify fully. Now, we'll deal with the top first, and what we're going to get is factorization. Basically, what you do is take the highest common factor between both the terms and then divide each term by the highest common factor. So in this case, the highest common factor is x, and then you divide x squared by x, you're going to get x, and plus 6x divided by x is plus 6. Okay, so now the bottom. So what you need to know actually before we do the bottom is this rule, basically. A squared minus b squared is equal to a plus b times a minus b. Alright? So that means that the only way we can factorize this is putting it in this form. So x is already in this form. X is already kind of like a. But 36 isn't in this form. 36, however, can be put in this form because 36 can be written as 6 squared. So that means that this can become x squared minus 6 squared because 36 is just 6 squared. So it becomes x times x plus 6 over, this is kind of like your a, and this is kind of like your b. So it becomes x plus 6 times x minus 6. So this and this divide to form 1. So 1x or x over x minus 6. So this is the simplified form. Alright, so question 19a. There's this guy called Ashok, and he takes 6 coins. He has 6 coins in his pocket. 1 5-cent coin, 2 10-cent coins, and 3 20-cent coins. So he takes a coin out of his pocket. So a coin comes out of his pocket. He looks at it, and then he just records the number and he puts it back into his pocket. So the coin goes back into his pocket. Alright? So he then takes a second coin and records its value. So he takes the coins twice and he replaces them and he puts them back in his pocket. So there's the same number of coins always in his pocket. So first of all, for 19A, you have to calculate the probability that he takes two 20-cent coins. Now, let's say he takes the first coin out of his pocket. What is the probability of him taking a 20-cent coin? It's nothing but 3 out of the total number of coins, which is 6. So the probability of him taking a 20-cent coin is 3 out of 6. Now, he takes a 20-cent coin, let's say, the first try. He looks at it, then he puts it back into his pocket. So he still has 6 coins in his pocket, right? So what is, and let's say he takes out another, let's say again, for the second time he takes a coin out of the pocket. What is the probability of it being a 20-cent coin again? It's still, again, 3 out of 6. So, to find the total probability that he picks two 20-cent coins, it's nothing but 3 out of 6 times 3 out of 6, which is equal to 9 out of 36, which simplifies to 3 over 12, which simplifies to 1 over 4. Okay, next question, 19B. You're being asked to calculate the probability that the second coin he takes has a higher value than the first coin he takes. Now, first of all, you got to establish that the lowest value coin is the 5-cent coin, right? So nothing can go lower than that. So, let's start off with the 5 cents. Let's say in his first try, he takes a 5-cent coin out. On the second coin he takes, it could be higher if he took a 10-cent coin out, right? So this is one event that could occur. Another possibility that could occur is he takes a 5-cent coin. Sorry, I made a small mistake. Let's start again. Basically, the lowest number is the 5-cent coin. So let's work from the 5-cent coin and figure out the events that could occur. Basically, if he picks a 5-cent coin first try, he could get a number of a coin that could be higher than the 5-cent coin is if he picks a 10-cent coin or a 20-cent coin. So the probability of this occurring is not, this is one event, forget the probability, we'll deal with that later. The second event that could occur is if he picks a 10-cent coin first try, and then a number that would be higher is a 20-cent coin. So on his second try, he picks a 20-cent coin. Right? So now let's calculate the probabilities of these two events occurring. So first, picking up a 5-cent coin is 1 out of 6. And this gets multiplied by picking up a total probability of 10 cents or 20 cents, which is nothing but 5 out of 6. And the probability of the second event of him first picking a 10-cent coin is 2 out of 6 times the probability of him picking a 20-cent coin, which is 3 out of 6. Now if you add these two together, you're going to get your total probability. So let's put that into an equation. So this is nothing but 1 over 6 times 5 over 6, the probability of the first thing happening, plus 2 over 6 times 3 over 6. Alright, so that just simplifies to 5 over 36 plus 6 over 36, which is equal to 11 over 36. If you want, there is another way you can do it actually. I'm just going to show you quickly. Basically, instead of taking that, remember that first event I calculated as one event, the two events that could occur is you pick a 5-cent coin, then a 10-cent coin, then you pick, or another event that could occur is a 5-cent coin, then a 20-cent coin. 20 cents, sorry for the bad handwriting. And the third event that could occur is 10-cent coin, and then you pick 20 cent. And but it'll still be the same answer because basically the addition of both of these is the same as the first event, which I showed in the previously. Alright, question 20 is a bit of a tricky one. It's like, it's A, B, and C are points on horizontal ground. And basically, if you look at it, it's actually a 3D shape, where this is kind of like the 3D bit. That's the 3D bit. This is the flat bit over here. Okay? So basically, I think I'm going to do this in different colors. I'm not going to stick to my red because it's going to be difficult to understand. So what they're saying is angle A, okay, right, from here, the angle of elevation, meaning for this triangle over here, the angle of elevation here is 13 degrees. And for this triangle here, the angle of elevation at C is 19 degrees. So you're being asked to calculate AC. Alright? So what you need to do first is, you've got this side. Okay? So if I find this side, we'll call it X. And then I find this side, we'll call this Y actually. That means this plus this squared will give me hypotenuse squared, because if you look, it's a right angle. I know that's a bit complicated to see, but basically we'll work from the beginning and hopefully you'll understand what I'm trying to do. So I'll draw the first triangle and we'll deal with the first triangle. So we have an angle here of 13 degrees and we have the adjacent angle, and we know that this is a right angle also. Okay, so over here we need to find the opposite side, which is x. So what function relates the opposite side and the adjacent side? It's nothing but the tan function. So tan of 13 is equal to opposite, which is x, over adjacent, which is 40. So x is equal to 40 times tan 13, which is equal to 9.23, and this is correct to three significant figures. So 9.23 meters. Alright? Now, we're going to deal with this triangle over here. Okay? Now this angle of elevation is 19 degrees. And this side over here is 9.23 meters, because we calculated from the previous triangle. So again, it's a right angle triangle. So we can apply the SOHCAHTOA. And we have the opposite side, but we need this side over here. Alright? So that is the adjacent side, and we have the opposite side. So again, the function that relates them is the tan function. So tan of 19 is equal to opposite, which is 9.23, over adjacent, which is, we'll call it y. We'll call this y over here, right? So over y. So y is equal to, multiply both sides y and divide by tan 13. You're going to get y is equal to 9.23 over tan 19, which is equal to, so y is equal to about 39.97. So we'll just say, round it to three significant figures, we'll say it's 40. Alright? Oh, actually I made a small mistake again. On the calculator, I typed in 13 instead of 19. So I got, actually it's supposed to be 26.8 meters, and this is correct to three significant figures. So it's 26.8. Forget that 40 which I was talking about. It's stupid of me. Okay, anyway. So now we know that y, which is this side, is equal to 26.8 meters. So now we're going to deal with the final horizontal triangle, and this is our final step to solving this question finally, at last. Okay, it's a horizontal triangle. Again, it's a right angle triangle. We have two sides. Alright? Now we just need to calculate the hypotenuse, because this is opposite. So we need to calculate the hypotenuse, which is AC. So AC, what is AC? I hope you remember your Pythagoras theorem, which is AC squared is equal to the other two sides, the square of the other two sides added together. So 40 squared plus 26.8 squared. So AC squared is equal to 2318.24, right? Now square root both sides. You're going to get AC is equal to square root of 18.84, which is equal to 48.1 meters, and this is corrected to 3 significant figures. Actually, this is not the actual answer in the what do you call it, the mark scheme, because I kept rounding this off. For example, I rounded this length off over here. So what you need to do is not round the lengths off and just use the exact lengths which are on your calculator, and you'll get the right answer of 48.2. So sorry for that. Okay, so we're finally on our last question of this stupid paper, and I'm going to continue in my red again because I'm just in the mood. So over here we have to solve the simultaneous equations. In this case, y is equal to 2x squared, but y is also equal to 3x plus 14. This means that 2x squared is equal to 3x plus 14 because y is equal to y, right? Next, so we've established that 2x squared is equal to 3x plus 14. So 2x squared minus 3x minus 14 is equal to 0. Now, to find values of x, all we have to do is solve this equation for 0. So you just got to factorize this quadratic function. So in this case, we're looking for two numbers that multiply to give me 2 times 4, negative 14, and add to give me negative 3. So we're looking for two numbers that multiply to give me negative 28 and add to give me negative 3. And if you think about those two numbers, they should be negative 7 and plus 4. So you just split this original equation into negative 7x plus 4x minus 14 is equal to 0. So now you factorize each side separately. So you take, in this case, you take the highest common factor, x, you're going to get 2x minus 7 plus 2, which is the highest common factor, 2x minus 7. Now what you do is you're basically factorizing 2x minus 7 out of the whole equation, out of all of this. So you're taking 2x minus 7 as a factor. So 2x minus 7 divided by 2x minus 7 is x, and plus 2x minus 7 divided by 2x minus 7 is plus 2. So this is both equal to 0. So that means, wait, I'll actually erase all of this and continue above. Okay, so what this means, I'll continue up here. If I divide both sides by x plus 2, right? I divide both sides by x plus 2, divide by x plus 2, it's going to be 2x minus 7 is equal to 0. So x is equal to 7 over 2. And the same thing will happen if I divide both sides by 2x minus 7. But in this case, x will be equal to negative 2. Alright, so now you have two values of x equal to 7 over 2, and x is equal to negative 2. But now you just need a y value. So all you got to do is take each of these and substitute back into any of the equations. So I'll substitute this into this equation and the other into the other equation. So all I'm going to do is say y is equal to 2 times 7 over 2 squared. So y is equal to 2 times 49 over 4, which is equal to 49 over 2. Now I'll substitute the negative 2 into this equation here. I'm going to get y is equal to 3 times negative 2 plus 14. So y is equal to minus 6 plus 14, which is 8. So your final solutions are x equals 7 over 2, y equals 49 over 2, and x equals negative 2, y equals 8. These are your solutions. Okay, so we're finally done with paper 3H from June 2010. So please comment if you have any questions, and rate this video, and also subscribe to my channel. So thanks guys for watching, and I'll see you in the next tutorial.